This, as you can see, is a right-angled triangle. It is called a right-angled triangle because one of the angles is a 90 degrees represented by a box. Now, the labeling of the right-angled triangle is very important. The box, which is in 90 degrees, or the 90 degrees represented by the box, is always pointing to the hypotenuse, as you can see. So as you can see, the hypotenuse is right across from the 90 degrees. Now, this vertical side, there are two names it can be called with reference to the angle alpha and theta. So if you want to make reference to the angle alpha, you have to say this vertical side is adjacent to alpha because it is next to alpha. If you are referring to the angle theta, or that very same vertical side, you will have to say it is opposite to theta because it's away from it, from theta. Now, this horizontal side applies also. As you can see, it is next to theta, so it can be called adjacent to theta. However, it is opposite to alpha. It is away from alpha and can be called opposite to alpha. So the hypotenuse depends on the 90 degrees of the box, and the other two sides depend on the acute angle that you are referring to. So now, if you have an example like this one, as you can see, this side here is opposite. Well, the hypotenuse, as we say, is always opposite from the 90 degrees. This side is opposite to alpha, and that very same side is adjacent to theta. This side here is opposite to theta, and this very same side is adjacent to alpha. So now I would like you all to take out your pencil, your pen, and your paper, your notebook, and to draw this triangle as accurately as possible how it is. You have a horizontal line and you have two diagonal lines here, and you have a box represented right there, and alpha and theta. So I'll give you a moment to draw this triangle as accurately as possible. Right, so what we can do now, we can label the triangle. Okay, so we'll start with this horizontal side right here, the side that connecting alpha and theta. What name would you give that side? That side right here, that horizontal side. What name would you give that side? So this side that connecting alpha and theta, this side right here, is called the hypotenuse. And the reason for that, because the 90 degrees box is pointing towards it. So we're going to label this side the hypotenuse. Now, this left side here, this side on the left side that connecting alpha and the 90 degrees. Alpha to 90 degrees, this side here, that left side, there are two names we can call that side. Please, let's try to identify one of those names, and then we'll identify the other. So therefore, in these options, 1, 2, 3, 4, the correct one for one of the correct ones, there are two correct ones for this side, and one of them is adjacent to alpha because it is next to alpha. So we can correctly call that side adjacent to alpha. And we can label it like that, adjacent to alpha. But there's another name there's another name we can give that very same side. Apart from adjacent to alpha, what else can we call that very same side? This side can also be called opposite to theta because, as you can see, it is away from theta. So you can also call this side opposite to theta because it's right across away from theta. So you can say opposite to theta. Now let's come to this side there now. This right side here that connecting 90 degrees to theta. Oh, well, we are left with the two names, as you can see, adjacent to theta, because it is next to theta, and opposite to alpha, because it is away from alpha. So it's a giveaway because the two other options are here. So we can just, but we know why. We know why it is called adjacent to theta, because as you can see, theta is right next to it. And we know exactly why it can also be called opposite to theta, because it is right across away from opposite to alpha, because we can see this right across away from alpha. So please copy this down. Always remember, when you're looking at a math video, you always have a pen, pencil, and paper, your calculator, your ruler, all your math instruments to be participating in the video. So let's move on to another triangle that does not have a 90 degrees. And let's call it the oblique triangle. Now, the oblique triangle does not have a 90 degrees. It does not have a box. So any triangle that does not have a box, you must not mention the word hypotenuse, and you must not mention the word adjacent. I repeat, any triangle that does not have a box and you want to describe it, you want to talk about it, you must not use the word hypotenuse and you must not use the word adjacent. The only word you can use is opposite, because the rule is that the side that is opposite to the angle carry the same letter. The uppercase is for the angle and the lowercase is for the letter. So side A is opposite to angle A. Lowercase, uppercase. Side B is opposite to angle B, and side C is opposite to angle C. Here's another example with the use of PQ and R. And as you can see, side R is opposite to angle R, side P is opposite to angle P, side Q is opposite to angle Q. Sides are given the lowercase and the angles are given the uppercase in the labeling. So please take out your pencil, your paper, if you have it already, get ready to write. I would like you to draw an oblique triangle as accurately as possible, like the one that is represented here on the screen. No 90 degrees. So as an exercise to label this triangle, we're going to use the letters L, M, N. L, M, and N. So I'm going to take capital M. Give me an angle anywhere you would like me to put capital M. So we have chosen to put capital M in this top right corner. So this is angle capital M. Help me to choose a corner to put capital N. Top left or bottom? So let's put capital N there. And obviously capital L has no choice to go on the top left. Right. So this horizontal side, LM, the side LM, how can we appropriately label the side LM? The side LM, because it is opposite to the angle N, capital N, let's call it small n. What about side NM? How can we call it? Small l, because it is it is opposite to angle L, and obviously side LN is appropriately labeled M because it is away from angle M. As you can see, no hypotenuse, no adjacent. It's side and opposite angle. Side and opposite angle, side and opposite angle. That's the labeling for the oblique triangle. All of this in preparation for trigonometry in the CXC exam, and we can compare what we have done to the list of formulas. So please get out your list of formulas before we move on, just to compare what we did with the information in the list of formulas from the CXC syllabus. Right, so I go into the Google Classroom in the CSEC math information and click on the CSEC list of formulas. Here they are. And as you can see, it begins with the volume of a prism, volume of cylinder, volume of pyramid, circumference of circle, arc length of circle, area of sector, area of trapezium. All of this is geometry. Okay. And here are the formulas. Here we have the formula, the algebraic formula, that's algebra. And below here are the formulas for trigonometry. Sine, cosine, tangent, area of triangle, sine rule, and cosine rule. Trigonometry, tri means 3. Gonometry, a shape with 3 sides and 3 angles called a triangle. And here you have a right angle triangle and an oblique triangle. And you can actually see the comparison with how we labeled it with what we just did. So as you can see in the list of formulas, the right angle triangle has the box, the hypotenuse pointing out, the box, the 90 degrees is pointing away, pointing towards the hypotenuse, as you can see, just like our own. And they only have one angle called theta. So we can clearly appreciate why this side is called opposite, because it is opposite to angle theta. And this side is called adjacent because it is next to angle theta. But if angle theta was up there, that vertical side would be called adjacent to theta, and this horizontal side would be called opposite to theta. But because angle theta is here, this side is called adjacent to theta. You see, they didn't write to theta, they just write adjacent. But it's supposed to be adjacent correctly, completely written, adjacent to theta and opposite to theta. Now, the oblique triangle, as you can clearly see, is similar to what we have. Small a, capital A, small c, capital C, small b, capital B. This box there is the vertical height. So this box is not part of the triangle. It's just telling you this here is the vertical height of the oblique triangle. Okay. Now, always remember, with an oblique triangle, there is no hypotenuse, and you must not mention the word adjacent. It's just opposite.